Hello and welcome back to another Max for Live tutorial. Today we're gonna try to build a Stereo Imager plugin in the style of the Ozone Imager. So at first we are opening up an instance of the original Ozone Imager, because by opening up the user interface we already get a lot of information of how the plugin is actually working. When we hover with our mouse over the parameter, there's a little text field popping up, where you can see what the parameter is actually doing to our signal. As you can see, the width parameter is actually just the gain scaling factor for our side signal content, where 100% is doubling the gain of our side signal information, 0% is no change in our side signal information, and minus 100% cuts all of our side signal information. The stereo button over here is basically just the on and off switch for the algorithm, which synthesizes extra side channel content for our signal. By enabling it, you can see that the delay parameter is also enabled, which sets the delay time for our stereo algorithm, and it goes from 20 milliseconds down to 1 millisecond of time. The Ozone Imager features two different algorithms of how stereo signal can be created. We just keep on focusing on the first algorithm, where basically a copy of the mid signal is delayed and then injected into our side signal. Now we delete all of that and try to replicate these algorithms with our max objects. At first, we have to convert our left and right signals into mid and side signals. So we do that with a thing called mid-side matrix. So we start out with our plugin object, and the mid signal is basically the sum of the left and right signal. So we create a plus operator and connect the left and right signal to it. And the side signal is basically the difference of the left and right signal. So we create a minus operator and connect the left and right channel to it. Now to scale the signal the right way, we add a multiplicator and add 0.5 and connect it to the mid signal and also to the side signal. We're gonna drag this one down a little bit because we have to inject more stuff here later on. And now we convert our side signal and mid signal back to left and right with the same way. Add a plus operator and add the mid and side channel content and a minus operator for the mid and side channel 2. And these two we will connect to the plug out object, which is routing our signal into Ableton later. We now just scale this one and move around these operators a little bit to make a little bit more space for the things we have to add later. And we also start to label our things here just for a little bit better understanding. So as you can see here, this is our mid signal, and on the other side we have our side signal. And then down here we converted our signal to back to left and right. Actually, it's the other way around. Now we should add the parameters we have to work with. So we create a live.numBox and give it a value from -100 to 100 with an initial value of 0. And yeah, percent seems to be a good value for it. Just add the width name so we don't get confused later on. Now we copy all of that. For our delay parameter, which has a range from 1 to 20 milliseconds with an initial value of 6, and we change percent to a time value. And also change the comment to delay. And then the last parameter is our stereo rise parameter. For that, we gonna use a live.text object. And we will label it just with an on or off message. And that's kind of it. We now can simply connect these multiplicator to the right outlet of our width parameter, because that's actually just what it does. The width parameter only scales the gain of our side signal content. So on center position, it puts out a 0.5, which is actually no change. At 100% a 1, and at -100% a 0, which basically is just the amplitude of our side signal content. That is actually the same way the width parameter in the utility device inside of Ableton works. So now for our stereo rise algorithm, we add a delay object, which we connect to our mid signal right over here. And we're gonna add this one to our side signal content. Now we can connect our delay object to our delay parameter. But there's one thing we have to check, because if we hover over the inlet, it tells delay times in samples. So we now have to convert our millisecond delay time into a sample delay time. And there's a little object for that, ms2sams, which just does all the conversion stuff for us. So now we add a little multiplicator, which we connect to the delayed signal. And this one we connect to our stereo rise parameter. So if we turn it on or off, our delayed signal will be 0 if it's off and 1 if it's enabled. So now we come to the part which is a little bit more mathematical. We add another multiplicator here. And the width parameter actually scales our delay signal too, but only for the values from 0 to 100. So we have to multiply the right outlet by 2 and then subtract it by 1. So this way, also do a little label here, we converted the outlet from 0 to 1 to a value from -1 to 1. Now, because we just want to work with the values from from 0 to 1, we add a clip operator with the values 0 and 1. And this will make sure that everything below 0 will be clipped to a zero value. Now we connect this to our second multiplicator. So now just have a little look at that. As you can see, everything below 0 is 0. And if we go up from 0 to 100, it scales from 0 to 1 in a linear way. And this is basically the basic algorithm of the device. So now let's have a little check what it's actually doing to the signal by loading up our Bertham EQ curve analyzer. Actually 2 instances. One connected to the output and one to the input. When we now open it up, we can see the EQ curve. And when we enable our stereo rise parameter and add a little bit of delay and width, we can see we add quite a bit of peaks and notches over there, which is exactly the opposite on the left and right. By scaling our delay time, there will be more or less of these peaks and notches. And the cool thing is, if this all is summed to mono, we will have basically just a bypass of our stereo rise parameter, so it's full-on mono compatible. And that's basically what Ozone Imager is doing. But we can extend that a little bit more. If we add a biquad operator right here at the end of our side signal, we can remove the unwanted stereo information from the base range of our signal. So we create a filter coefficient object and declare it as a high pass filter. And then we connect the biquad to our filter coefficient outlets. Drag it over here and route our patch cords. And now we create a live.numbox object for our cutoff value. Under prototypes, we already have a frequency numbox. And then we have to deal with the Q value of our filter. And for that, we can basically just hard code it. So we get a signal operator and type in 0.7071. This is basically the rounded value of the square root of 1/2. And we use this value because this doesn't add any kind of resonance at our cutoff frequency. So we get a pretty linear phase response from there. We should also adjust the values of the frequency number box over here because 0 is not a good value to start with. So we just declare the range from 50 to 4000 or something like that. This should be a good range to work with. So now if we open up our EQ curve analyzer and activate the stereo rise effect, and now you can see if we move around our filter cutoff, we just remove the unwanted frequencies in our bass region. Okay, now we can just close the EQ curve analyzer, and maybe we label also the filter part. This is just a 12 dB per octave high pass filter. If you want a steeper roll off, you can just add another bi-quad filter in serial with the same coefficients. So this will add up to a 24 dB low pass filter. Now we just remove the EQ curve analyzer, and this is basically our finished patch. Now you can just add the user interface object to the presentation mode, drag them around the way you like them to be, create a little user interface, and then you have a little Stereo Imager Max for Live device to work with. As always, if you want to support my work, there's my Gumroad shop linked in the description below. There you can download my Max for Live devices and make little donations if you want to. And you can also subscribe to the YouTube channel so you don't miss out on further tutorials I do. Until then, have a nice day, and I see you in the next tutorial.